In this video, I'll consider one numerical on node analysis. Find the power supplied by 10 volt source for the circuit shown below. This is the given circuit. We need to find power supplied by 10 volt source. So here we have 10 volt source. We need to find power supplied by this 10 volt source. I will solve this using node analysis. So here we can observe that this is the node. We'll assume voltage at this node is V1. Let voltage at this node is V2. So in node analysis, first we have to mark all branch currents. Let me assume current through this branch is I1. Let current through this branch is I2. Let current through this branch is I3. And current through this branch is I4. So here we have already a current source. That is, here we have voltage dependent current source. It is dependent on voltage V3, where V3 is voltage across 4 ohm resistor. We can write here V3 is nothing but voltage across 4 ohm resistor, that is 4 into I2. 4 into I2. Now let me apply KCL to node V1, that is apply Kirchhoff's current law to node V1. So according to KCL, incoming current is equal to outgoing current. Here at this node, no any currents are incoming. So I can write 0 equal to 10 I1, I2 and I3 all are leaving the node. I can write 10 plus I1 plus I2 plus I3, or I can write 0 equal to 10 plus I1 can be represented as V1 divided by 2, V1 by 2 plus I2. I2 can be represented as V1 minus V2 divided by 4. Along with that, there is a voltage source, so it should also be considered. So it will be written as V1 minus V2. Here we have voltage source, that is minus of minus 10 whole divided by 4. So plus I3. So I3 is the current which is flowing from V1 towards V2. It can be represented as V1 minus V2 divided by 2. Let me simplify, that is 0 equal to 10 plus we have V1 by 2 plus V1 by 4 minus V2 by 4 plus 10 by 4 plus V1 by 2 minus V2 by 2. So let me simplify, that is 0 equal to we have 10 plus V1, here we have 1 by 2 plus 1 by 4, and here we have V1, that is 1 by 2 minus here we have V2. I'll take V2 terms, that is V2. Here it is 1 by 4. Here we have one more V2, that is plus 1 by 2. And here we have 10 by 4, that is 2.5. I will simplify this further, that is 0 equal to, here we have 10 plus 2.5, that is 12.5. 12.5 plus here we have 1 by 2 plus 1 by 2 is 1, and this is 0.25. So it is 1.25 V1. So it will be 1.25 V1. Here we have 1 by 4 plus 1 by 2 is 0.75. That is minus 0.75 V2. Or I can write 1.25 V1 minus 0. We have 75 V2 is equal to, I'll take this 12.5 other side, it will become minus 12.5. Let me call it as equation 1. Now similarly we have to apply KCL to node V2, that is apply Kirchhoff's current law to node V2. So here at this node current I3 is incoming, I2 is incoming, 4 V3 is incoming and I4 is leaving. So I can write I2 plus I3 plus 4V3 is equal to I4. That is incoming is equal to outgoing. Or I can write I2 plus I3 plus 4. So already V3 is equal to 4I2. That is into 4 I2 is equal to I4. Or I can write here it is I2 plus I3 plus 16I2 is equal to I4, or I plus 16I2, that is 17I2 plus I3 is equal to I4. Further, I can simplify this as I2 is nothing but V1 minus V2 plus 10 by 4. So I can write 17 V1 minus V2 plus 10 whole divided by 4 plus I3, that is plus. So I3 is nothing but V1 minus V2 by 2, that is V1 minus V2 by 2 is equal to I4. I4 is nothing but V2 by 1, that is V2. Let me simplify. 17 by 4 is 4.25. We have V1 minus V2 plus 10. Here we have V1 by 2 minus V2 by 2 is equal to, I'll take this V2 on left hand side, minus V2 is equal to 0. Or I can write 4.25 V1 minus 4.25 V2 plus 42.5 plus this is 0.5 V1 minus 0.1 by 2. This is 0.5 and this is 1, that is minus 1.5, that is minus 1.5 V2 is equal to 0. Further, I can simplify this as, here we have V1 term, here we have V1 term, that is 0.25, 0.5, that is 4.75. 4.75 V1. So here we have V2 term, here we have V2 term, that is 4.25 plus 1.5, it is 5.75, that is minus 5.75 V2. I'll take this 42.5 on other side, it will become minus 42.5. Let me call it as equation 2. Now we need to solve equation 1 and 2 to find the value of V1 and V2. That is, solving equation 1 and 2, we get. So I will solve equation 1 and 2 directly using calculator. So keep calculator in equation mode, that is fifth option. Here we have only two unknowns, choose first option. So here feed the values of coefficient of V1, V2. That is coefficient of V1 is 1.25, 1.25 plus equal, then press coefficient of V2, that is minus 0.75 equal to, then C value is nothing but this value, that is minus 12.5. So similarly, now feed the values of second equation. So here coefficient of V1 is 4.75. 4.75 is equal to, here coefficient of V2 is minus 5.75. 5.75 equal to, then its value is minus 42.5. That is minus 42.5. So it gives V1 is equal to minus 11.03 and V2 is equal to minus 1.724. So therefore I can write V1 is equal to minus 11.03 volts and V2 is equal to minus 1.724 volts. So these are the values of V1 and V2 which are calculated using node analysis. Now it is asked to calculate power supplied by 10 volt source. So power supplied by this 10 volt source is nothing but P is equal to VI. V is 10. So current through in this branch is I2, that is 10 into I2. So we need to find power which is 10 into I2. So I can write P is equal to 10 into I2, or I can write P is equal to 10 into, so I2 is nothing but V1 minus V2 plus 10 divided by 4. Again go to the complex mode, compound mode. So here we have V1. V1 is minus 11.03 minus 11.03 minus V2. So V2 is minus 1.72, that is plus 1.724 plus 10, that is plus 10 is equal to, so divided by 4, that is divided by 4, we got this value into 10, that is into 10. So it gives 1.735. Therefore, power supplied by 10 volt source is 1.735 watts. P is equal to 1.735 watts. This is the power supplied by 10 volt source, and it is calculated using node analysis. Thank you for watching.